Hello everybody, welcome back to my channel. In this tutorial, we are going to learn about how to create matrix in our programming language. So let's start. What we're gonna do, like just change the language here. So we have, let's say, create a matrix. So we should first state the name of our matrix. Let's call it matrix data. So we have matrix function for this. So we should write our data. What's our data? In this, I am just use the sequence from 1 to 12, and we should state number of row. Let's call it 3. And we should state number of column. Let's call it 4. So now we should print our matrix data. Just matrix data. So we see that we have number of rows is 3 and number of columns is 4. So we should know that we have 12 entries. So the multiplication of number of row and number of column must be equal to the number of entries. So let's learn how we add the matrices. Addition of matrices. So first, we should state our two matrices. Let's say first we have matrix A. As you know, we already know how to create the matrix. We should state our data, and we should state number of row. Let's call it 2. And let's state our matrix B, and it will be 7 to 12, and let's call it as number of row is equal to, again, 2. And now we just write results at this. So we have simple plus sign for doing this. Matrix A plus matrix B. Let's print our result. Print results at. You can see we just add the rows and columns, each entries. So we have 6 data for each matrix. So we just add the all entries, the corresponding entries for both matrices. So let's learn how we multiply them. So there's addition of matrices. So again, let's state our matrix C. And again, we have used matrix function. Let's say it is 1, 2, 4. And we have, and number of row is equal to 2. And let's state our matrix P. And this is equal to matrix 5, 2, 8 sequence. And again, we have number of row is equal to 2. So let's just say result multiplication. That's short form of multiplication. And we have matrix C, percentage sign, star sign, again, percentage sign, matrix D, and let's print our result. How this multiplication of matrix works? So we just multiply the first row of the matrix C to first column of the matrix D, and also first row of matrix C to second row of matrix C the second column of matrix D. So in order to do that, the number of row of matrix is equal to must be equal to number of column in second matrix. Without this, we can multiply them. So you know that we have 4 entries and number of row times number of column must be equal to 4. If we state just number of rows is 2, so it means the number of column is also 2. And if the number of column number of row of this matrix is 2, so number of column of second matrix it has 4 entries, so they are equal, so we can multiply them. So let's learn how we find transpose of the matrix. Oh, matrix. What's the transpose? Transpose is we just change number of place of number of place the column and row. For example, first row will be our first column, and vice versa. First column will be first row. So let's state our original matrix. And again, let's create our matrix. So matrix function again. Okay, this 6, and we state number of row is equal to just wrote capital, and row is equal to 2, and we just state our transpose matrix. Again, we have function. Can you guess what is it? It's just T. We just wrote original matrix. We just print our transpose matrix. So if we look at this, we have like, let's look at original matrix. Okay, let me just copy this and paste this here. Let's see what's our original matrix, and let's see what's our transpose matrix. Let me just print this origin. No, let's see how they change. Let's see. This first column became our first row. This second column became our second row, and this third column became our third row. So if you have a matrix, okay, we should know what's the dimension of the matrix. I mean, how many row and how many column it has. For example, maybe we upload our data, and we should know that how many like row and how many column it has. So we try to learn this. So let's see. Let me just put it as a get dimension of a matrix. So we just use, like, let's say our data is, we have just matrix theme, like dimension, we state our variable. So we use just dim function. Let's say we have already matrix data here. So we should know how. We already know how many it has. Let's check that it's correct or not. Let's say print matrix dim. So we have 3 row and 4 column. Let's see our matrix data here. We have matrix data. We have number of row is 3, number of column is 4. So it is correct. So if we want to find the sum of each row, if we want to find sum of each row, like sum of each row, how we can find it? We just use our apply function. I wrote it wrong, sorry. This apply function. We just state our matrix. Let's choose matrix data. And if it states 1, it means that you know that we just wrote one is our first. We state the row is just one because first things is row, and we just use sum. So 22, 26, and 30. This is sum of our row. So let's check it. Is it correct or not? So we have this first. This is our first row, and it states that it is 22. Let's add it. 1 plus 4, 5. 5 plus 7, 12. And 12 plus 10, 22. Let's check. Second one is 26. So 10, 15, 26. That's correct. And third one must be 30. So it is 9, 18, and 30. That's correct. Now let's see. We want to find mean of each column. As you know that what's mean of each column. We want to find it. Again, we use apply. So this apply functions apply if we want to apply the same function, same thing to most of the things, not just one thing. So we use this our function, apply function. Let's see, we have matrix data, and we have 2 that states our column, and we just use our mean function. So 2, 5, 8, 1. So again, let's check it. That's our first column in our matrix data. Okay, so mean of this 1, 2, 3 says it's 2. Let's add them and divide by 3. 6 divided by 3, 2. That's correct. And we have 5, 9, 15, 5 divided by 3. So 24, it is 8, and let's say 33 divided by 3, 11. That's correct. So let's assume that we have linear system. Like how we can solve it. Let's say solve a linear system. Linear system using matrices. So what does it mean? Let's say we have a bigger matrix. A is matrix. I'm sorry, again, just use capital matrix. We have column 2, 3, 1, 1. Let's say, and we stated the number of row is equal to 2, and let's close it. And we have second. So I will explain what is it. We have 8, 5, and so already know how many column it will have. So we have like answer X. So it will solve it by matrix A, B. So we have print X. It's -3 and 4. So what does it mean, guys? It means that if we have a system of equations, and this 2, 3, 1, 1 are our coefficient of the variables. So it's coefficient of the variables. So we just use it, and we just have like X and Y. So we just state have our variables like X and Y, and this is equal to 8 and 5. So we just solve it with system of equation. So maybe we need to find visualization then. Let's say we have heat map for them. Let's say create a heat map plot for them. So let's use our heat map. We have matrix data. And we just call it main is equal to heat map example, because we just use heat map example. You can see this is our variable. Okay, variable of X and variable of Y. So this shows you how